RPGSTART multi-body movement. Last lecture we just showing a Yoden, single Yoden moving at the center of the screen because the cameras are pointing to the position of the Yoden, although the Yoden is moving but look like stand still there, but running at all the same place. Today we try to show several Yodens, suppose 15 Yodens running along 90 degrees the face direction. And 15 Yodens movements altogether. The same. We open Visual Studio, Visual C++ 6.0 first, and open Workspace RPG1 in RPG demo rpg1.dsw. Open it and to see if the program still the same. Okay, the Yodens are running and turning the mouse, moving the mouse cursor. The Yoden will turning because the cameras turn around. Look at the position of Yoden. Okay, then we commence to enlarge from single Yoden to 15 Yodens running together. We change the program from winman.h. There is only one mesh, one Yoden, so C mesh, C character mesh, only one. But C object, we have 15. We have to open an array 15 of character objects, and the Yoden animation. So we have to open character animations with array 15. The 15 for each object has its own position. So as plus we have to open 15th array, the Y15, the Z15 as well. Okay, let's save all first. Then go back to winman CPP, start it. From CPP, the resolution don't care because in initial we'll define the resolutions. So started from initial. The graphic resolutions, okay, the mouse, okay. The only things we have to change is the single object change to multi-object. We open I variable first with should as the global variable put here. So later on, mid I, we don't need to announce it is a short. And go back to here. Remove the single character object first. And then write the new program here. So we load the character deltas. The first character mesh load, Yoden. The Yoden's mesh is only one. So the character mesh load graphics delta Yoden delta, it is okay. And then for the animations, we have character and animation load and character animation setup. We say 15. So we have to use a for loop. Copy. We have the global variable allowance I. So in here we don't need with the short in front. While from 0 to 15. And we have to do two things. Okay, 3 altogether. Copy. And paste to here. The first one is character animations with I index and the low Yoden character mesh single, don't need index at real. And the animation, character animation with I index same loop true and work. And then create objects. The object with I index, it will create 15th character objects. The object has to be located initially. Last time we put x at -800, z at -800. This time we want to use random to set the object position. So we copy this one and put down here first. The object I move with xi positions, with z pos I positions, while si positions defined by random. Last time we put around 2000 millimeters circle or square. Right now 15th, not 256 Yodens. So we cancel a 0 to random create and locate objects around the 200 millimeters radius. And then the z pos original locate randomly. By the definition. showing in here. Copy and put down here, and cancel 1 0. So thereafter, 15th Uden's object will create it within 200 millimeters circle. That's it. So the original positions locate the 15 character objects. So initial OK. Save all. While the shutdown more than 1, so we have to use a for. Tolerance I equivalent to 0 until 15, and the character objects I free to remove the space occupied. The character animations I free as well. The dimension is only character objects and character animation. The character mesh only 1, just free. That's it. Save all. And then to the fan, the ellipse still the same. Target time minus timer. The timer equivalent to timer target time after ellipse get with reset timers as target time. The timer's original at the beginning of the frame is timer equivalent to target time. So the mouse acquire, mouse read, OK. So we started the moving of the Uden. Original S move, Z move equivalent to 0. We suppose the 15th Udens moving in all the same speeds and the same direction, 90 degrees. So let's move calculated sine 1.57 multiply speeds. The speed definition is here. So we get the movements S move and the Z move. Update characters. We are not only 1 characters to move. We have 15. Definitely for each S plus we have to have index I. Therefore we need a for. Just put down here. For I equivalent to 0 less than 15th I plus plus S plus I plus X move Z plus I plus Z move. And if X move or Z move, anyone or all of them not equivalent to 0, then we have to do the object sets, set animation from the character animations individually. And for every objects we have last animations. We have to announce I here. But last animations is only 1. We use Control F2 to mark here Then we go back later on. We just press F2 to go to this line. We can see the last animation we defined at a local of frame routine. So we move to the global, just to the very beginning, put down here, and length not static, only long. The last animation for each object, character object, with one last animation. So we have an index array 15th marked there. Remove the original setting. Now where can we set the original setting of the last animations? We can put down in the initial as the I equivalent to I less than 15. The first things we just put down the last animation. I give the original setting -1. So they are after last I 0, 1, 2, 3, 4. Whenever the first times the last animations is -1, not a 0, so it will go down. And to set the last animation, I be 0, and the character objects set animations will running. And after the animation settings finished, then we have to move the character objects to S pose with itself positions. So X pose we with I index, Z pose with I index. Now S pose here, the Z pose calculated in here. So that's all. So thereafter, the 15th character objects move to the new position, and then we set camera, set a flash trunk construct, then begin scene, end scene, and the object could be rendered. Okay, we don't use this chapter 13's camera settings. The camera point 2, the S position and the Z positions. We use the chapter 8's camera. Let's see chapter 8's camera. The chapter 8's cameras always camera move to 0, 0 original positions, but lift 100 millimeters high at the sky to look down to see the 15th Udens running. If don't move the mouse, the rotated relative will not move. Only the cameras always located at these positions, so we can see the really running, the really movements of 15th Udens running across, instead of always point to the Udens body, seeing no movements at all. If we use this one, although we look down at the single Uden, since the all 15th Udens moving all the same speeds, so the rest seems not move as well. Okay, then after this finished, we have to continue camera, set camera and frustrum construct, and then clear, use the sky blue as the background of the scene of the screen, and the graphic begin scene, and the graphic enable Z buffer, and then to render the object. For dynamic render the object, we have to use update animation first, and then issue character object render. Right now we have totally 15 character object, so we have to use a 4. To right here, remove shirt, the I from 0 less than 15. We have to update animation first, and then object render. The character objects, I update animation target time divided by 20 and the true, and then object character object I render. That's it. And then graphic and scene and graphic display. Let's see if there is any error. If without any error, we'll continue to run the program. Oh, 15 errors. Okay. The first things we have to change it back. The game code. To get the original RPG scan code, the Gene Aiden's original game code back, and go back to our RPG1 and continue rebuild all. Still plenty of error. Let's see in detail. Control F, error. The first things we move down here, missing the end of the lights, missing this one. Okay, the first errors removed. Rebuild all. Still 49. Control F, ERROR, error. For the cursor down here, and first press the left button of the mouse twice. It will show. Okay, here without this one. For loop. Okay, save all. And rebuild all. 30 errors. Continue. Control F, press together, and arrow, find next. Put the cursor here. It say this one missing, and press the left button fast twice. Where missing? Oh, here as well. We saw this one. So let's check if here we thought, okay, here we okay, no problem. Let's review all. Okay, right now 0 error. Then we'll start to run the new edit program. We expect to see the whole screen with resolution 1920 by 1080. According to the definitions in initial 1920 by 1080. Then we expect to see a Udon, 15 Udons created with animation. The 15th gathered inside a radius 200 millimeters and running along a directions 90 degrees. With running pause, faster move until outside a creeping window and vanished. This is what we expect to see. Let's see if it's correct or not. Start debug. Go. Take test. You can see some monster rush running across beneath. So we'll move the cameras to catch the view. Running again. Say debug. Go. 15. See, it takes time. So the circle running there. Okay, you can see that this is the direction. Originally, he ran from left towards the right. As we turn the cameras, it's running just into the screen. Okay, vanished. Run again and finish the demonstration. Go. Okay, 15. Crowded. Okay, maybe we can enlarge 200 suppose to 1 meters. 1000. Not so crowded. Where to change the random at the initial. So total suppose is 2000 and minus 1000. So the Udon, 15 Udons will create it around 1000 millimeters radius. Okay, let's compiler and then run again. Go. You see, 15, you can count the number. It's running and running until disappear. Ending.